So on this video, we are going to start talking about slope. And you need to be writing this in your notebook on page 91. So I'm going to start out by telling you a story about a time where I was encountering slope. So here's a picture of me a few years ago in Colorado at Rocky Mountain National Park. I was actually there on a math conference, and we got to go and see some beautiful mountains. And so this is a picture of me looking at one of the mountains and kind of showing it to you. When I think of slope, if you've ever heard of skiing where you hit the slopes, that kind of thing, then that relates really nicely to this picture. But I'm going to look at the slope of the mountain that I'm standing in front of. So that would be the slope, kind of its, how fast does it increase. Now, the problem is, how do I express this slope with a number? Okay, how do I tell you how steep it is using a number that you understand as steep? I could say it's really, really steep, and then you look at the picture and you're thinking probably that's not very steep. So instead of using kind of subjective terminology, we need to find a way to communicate the slope of different objects where we all speak the same language. Here's another picture. This is of us driving into Estes Park. Estes Park is a village kind of at the base of the Rocky Mountain National Park. And so we're about to go down into Estes Park, and we stopped at this sign to take a picture. But I use this one because I want to show you all the different slopes that you can see. So there's a slope here. Now how do I describe that slope? There's another one here. There's one over there with that mountain. There's one on that sign. There's actually two on that sign. But all of these have different slopes, and you needed a way to express that in numbers, not just by saying, well, it's more steep or less steep. So the slope provides us with a way to assign numbers to different steepnesses. It helps us speak the same language when we're talking about steepness. So back to here, now I've put this on a coordinate grid here so that we can kind of count units out. If I start at one point and I go up, see, I'm trying to get to that other point. But to get there, and I have to stay on the grid lines, I have to go up 6 units, and then I have to go over 16 units. Okay, so that's, if I was, that tells me kind of the distance or the way I'm getting from one point on the mountain to another point on the mountain. And slope, whenever your parents see this, they're going to remember rise over run, because that's what we were taught. Rise over run, rise over run. Well, the rise is that 6 units that I had to move up to get to the second point. Okay, and then the run is the 16 units I had to use to get from the first point to the second point. So the slope is 6/16, and that's how we would describe the steepness of this mountain. So I'm going to simplify this by dividing both by 2, and I get 3/8. So a lot of us don't like fractions, but with slope, fractions is really, really important. It actually makes our lives easier, so we want to keep it in fraction form at all times, unless we're dealing with something like money, and you'll see those situations as we get to them. So the steepness of this mountain can be expressed as 3/8. Here's a different picture that's got some slope to it, and I want to know, is this slope here more or less steep than the last one? Okay, the one of the mountain. So is it, hopefully whenever you look at it, you think, oh wow, this is definitely more steep. But we need that number to express that it is larger than 3/8. So I'm going to put 2 points and see how far apart they are. So it goes 16 units up to get to that second point, and 21 units over. So again, slope is rise over run, and the rise is at 16 units up that we went, and the run is the 21 units over. We can't simplify this any further because they don't share a common factor. So we're going to compare it to the 3/8 of the mountain. Now, I know that you guys love comparing fractions, but we really don't have to overthink this too much. I know that 3/8 is less than a half because 1/2 would be 4/8. And I know that 16/21 is more than a half because 10 1/2 would be half of 21. So that tells me that this picture shows a slope that is more steep than the mountain. So the big idea behind slope is that slope is one number showing the steepness of a line. So let's compare and see which one's more steep. I have a line with a slope of 1/2, a line with a slope of 3/4, and a line with a slope of 5/6. To do this, we need to compare it with common denominators so we can easily see the difference. And you may automatically see, well, obviously 3/4 is bigger than 1/2, but just in case and kind of to refresh your memory on how we do this, we're going to do multiples of 2 until we get to a multiple of 4 and 6 as well. So we have 2, 4. Now 4 is a multiple of 4, however it's not a multiple of 6. 6, we could just do that right there, and that means that my common denominator would be 6, so this is going to be 3/6. Oh wait, I'm sorry, that's wrong. Sorry. Okay, 6 works, but it doesn't work for 4, so we're going to keep going to 8. Let me erase this. Okay. 8 is a multiple of 4, but not of 6. Then we have 10 and 12. 12 is that least common multiple that we're looking for. So we have 6/12, 9/12, and 10/12. So our slope with 5/6 is the most steep. This is our first strategy. We're going to look at the foldable that's on page 90. But I wanted you to write this stuff down on page 91 so that you have a really good in-depth understanding of slope.